another session of Concept at Fingertips. This is Vidya, Physics faculty from Acharya coaching. Today, let us see the topic heating effect of electric current. So we know that we use battery or other electrical source to maintain the current in a circuit. We need a source of electricity to provide the required potential difference so that the electric current is maintained in a circuit. So a part of this source energy is used in the useful work, like example, rotating blades of a fan or doing a useful work. But the rest is spent as heat, and this will raise the temperature of the gadget we use. So when an electric current is passed through a conductor, it gets converted to heat. So this effect is called heating effect of electric current. So what is heating effect of electric current? When an electric current flows through a conductor, it gets heated. So the conductor gets heated. This effect is called heating effect of electric current. So what is heating effect of electric current? When an electric current flows through a conductor, it gets heated. That is, the electric current gets converted into heat. This effect is called the heating effect of electric current. So this heating effect of electric current is used in many appliances like electric heater, electric iron, toaster, etc. So let us see the mathematical relation for heating effect of electric current. So there is this circuit from NCERT textbook, and it shows a resistance and supply voltage or cell, and we have a key and voltmeter, a meter, and this is the basic setup for deriving the heat produced while an electric current is flowing through the conductor. So consider that an I current is flowing through the conductor, and there is the resistance of the conductor is R. So let the potential difference across this conductor be V, and it is measured by this voltmeter. So let I current flow through the resistance R for a time t. So because of this I current, let Q charge flow through the conductor in time t. Potential difference across the conductor is V. So what is the work done in moving Q charge through a potential difference of V? So from definition of potential difference, we know that the potential difference is defined as the work done in moving a unit charge. So it is given as V is equal to W by Q. From this relation, we can write W is equal to W is the work done in moving Q charge through the potential difference V. So W is equal to Q into V. So the source will supply QV amount of energy in time t. So in time t, the source will supply energy equal to Q into V. So we can say that the power given by the power delivered by the source as energy per unit time. So the power delivered by the source is work by time. We know that power is equal to work by time. So here we can say power is equal to QV divided by T, where T is the time and QV is the work done by the source in moving charge Q. So this same relation can be written as I into V, where I is equal to Q by T. We know that the current flowing through a circuit, it is the rate of flow of charge. So that is the definition for electric current. So from this relation, we can write power is equal to I into V or V into I. So power is equal to V into I. So from this, we can find out the energy supplied by the source. Since we have the power, we know power energy is equal to power into time. Or we can say energy supplied by the source in time t. In time t, the energy supplied by the sources is equal to V into I into T, because energy is equal to power into time. So this energy is utilized for heating the resistor. So this energy is dissipated as heat in a pure resistive circuit. Dissipated as heat. So we can say that heat dissipated is equal to H is equal to V into I into T. We'll continue here. H is equal to V into I into T. So from Ohm's law, V is equal to I into R. So substituting for this V in this equation, we have H is equal to IR into IT, or H is equal to I squared RT. So thus we got a relation for heat generated, heat dissipated in a resistance. So this relation is also known as Joule's law of heating. Is known as Joule's law of heating. So Joule's law of heating, let's rewrite it here. H is equal to I squared RT. So this relation implies that heat generated, heat produced in a resistance R is directly proportional to square of electric current for a given resistance. So this can be obtained from the above relation. The heat generated is directly proportional to, that is, H is directly proportional to I squared for resistance being constant, for a constant resistance. Also, we can see that heat generated is directly proportional to the resistance of the conductor. The resistance R of the conductor for a given electric current, for a given current. So what does it mean? It means that H is directly proportional to R for a given current, or if current is constant. The third thing that is evident from the relation is that the third point of the Joule's law of heating. Heat generated is sorry, heat generated is directly proportional to the time for which current flows through the conductor. Through the conductor having a resistance R. So we can say H is directly proportional to T, where T is the time for which the current flows through the conductor. So this is a very important law, Joule's law, and using Joule's law, we have many applications like electric bulb, electric fuse, electric heater, toaster, and many more.